So a couple different ways to do this one. I like to work within the parentheses, but some students like to just distribute this negative 5/6 to all of them. But I know if I only got two bases, x's and y's. So again, I still recommend stopping, just looking at the problem, seeing which way would be easier to simplify. Because if you distribute a negative 5/6 into all the exponents, it's a lot of work. Whereas if I just work with the exponents of just two different bases, then I can have just two distributions there. So that's what I'm going to do. I am not going to distribute the negative 5/6. Okay, so I'm just working on the inside of the parentheses, okay? So now you could work with all the x's, but you see those x's on the bottom, right? So I know from the x's, I have the x to the power of negative 5/7 on the top, and that's good. But there's nothing I can do with that. But what I do have on the bottom is x to the power of 1/2 times x to the power of 4/7. Now I'm not gonna worry about putting that into or working with that by hand. Okay, so what I want then is x to the power of 1/2 plus the 4/7, and so I'm still ignoring the x to the power of negative 5/7 on the top. But what I have then is 1/2 plus 4/7. Yeah, that's what I got too. So my denominator exponent is x to the power of 15/14. Now we go back and we see we got x to the power of negative 5/7. And applying the quotient rule for my base x means that you take the numerator exponent of negative 5/7, and we're dividing the bases, so we subtract the denominator exponent of 15/14. So again, I'm just putting this into the calculator to give me my new exponent for x, negative 5/7 minus 15/14, and it gives me a negative 25/14. Now, I'm not worried about flipping that fraction yet because this is part of my new parentheses with the negative 5/6 exponent, right? I now have an x to the power of negative 25/14. Now, if you did choose to flip this into a denominator, that's fine. It's not going to make a difference in the end. It shouldn't. But now that I have that, let's go to the y's. Okay, so I've got y to the power of 1/2 in the numerator, all over y to the power of negative 1/2 in the denominator, and this then becomes base y of 1/2 minus, because they're dividing the bases, minus negative 1/2. So you can put that in the calculator, but I know minus negative 1/2 there is going to make this y to the power of 1. But again, that's something I put inside the parentheses now, okay? So, this is what I have. Next up is just a distribution of the 5/6 right there, right? Now again, it's gonna keep the bases x and y. So that gives us this negative 25/14 times negative 5/6. And that will produce a new base x for me. So base x, let's see what this is on the calculator. So I got x to the power of 125/84, but then I gotta distribute that negative 5/6 to the y. So that's a 1 times that negative 5/6, which of course is just negative 5/6. So now I got my new y to the power of negative 5/6. Now, I don't want a negative exponent on this, so what I'm going to do is I'm going to change this into a fraction, right? So I got my fraction, I got my x to the power of 125 over the 84. But this negative 5/6, if I have a fraction like this, I can just move it to the denominator, and that will change the exponent from a negative 5/6 to a positive 5/6. And that's as far as I need to go on this one. That's good. Now just be aware, some students prefer to distribute the negative 5/6 into all the terms first. If you do, that's fine. You need to get the same answer here. We don't need to change these into their radical forms because these started out as exponents. So we're just going to keep these exponents as fractions, and that's okay.